Truth in My Days podcast is sponsored by the Truth in My Days ministry. Welcome to the Truth in My Days podcast, where we defend the Word of God against the challenges of men.
Carbon dating is one method of what's called radiometric dating. Mm-hmm. But carbon-14 dating is not used to date the age of the Earth. It's supposedly accurate only to about a maximum of 50,000 years.
Oh, okay.
So other types of radiometric dating is used. And
I see.
by radiometric, we mean radioactive substances that decay.
Right.
Okay? You know that radioactive substances are unstable, the nucleus, and they break down. Yep. Actually, you're an engineer. Why don't you explain to our audience what a radioactivity is?
So basically how we measure the decay of radioactive particles with something called a half-life. Every period of length in time, the amount of that substance decreases by half. And then again, after that same period, it decreases by half again, and then half again, and then half again. To do that, you have to assume a starting amount of that substance. And then if you have the starting amount and you have the half-life and you have the amount that you have now, you can calculate how many years it's been.
Yeah, exactly. Radioactive substances are unstable. The nuclei are large. They want to become stable, and they do that by kicking out particles or radiation. And you have different types of radioactive decay. But one thing they share in common is what's called a half-life. As Jason explained, you have a certain period of time, and it's different for different substances. Mm-hmm. But for that half-life, the amount of radioactive substance will drop to exactly 1/2 of what you started with.
Yeah.
That's why they call it half-life. For carbon-14, the half-life is 5,730 years. So if you start with, say, 10 grams of carbon-14, that's not really how you'd measure it, but for the sake of illustration, if you start out with 10 grams, after 5,730 years, you would have 5 grams left, half of 10.
Yep.
Then you wait another 5,730 years, you're down to 2.5 grams, half of the 5 you started with. And now you start with 2.5. After another 5,730 years, you're down to 1.25 grams. And so this is how you can figure out age from radioactive decay. You start with 10 grams, you're down to 1.25 grams. You know, therefore, it's gone through 3 half-lives. Mm-hmm. So your substance has to be 17,190 years old. Mm. That's how it works. You can calculate this mathematically. It's using a standard Newtonian decay curve, which you integrate, which our engineer could do here. Mm-hmm. And it comes out to this. The time, the age, is equal to the half-life divided by the natural logarithm of 2. So it's just a number. Multiplied by the natural logarithm of the amount of the substance you have now over the amount of the substance that you had at the beginning.
Right.
Okay? And so this is how it works. Let's give you a quick illustration of it. Suppose you have a rain barrel. To help you understand how this works, you have a rain barrel, and you find that this rain barrel has a capacity of 100 liters. And there's a leak at the bottom, maybe a spigot that's not closed properly. And you look at how fast water is leaking out, and you find that it is leaking out at a rate of 1 liter per hour. And you look in the barrel, you see it's half full. Question then is, how long has the barrel been leaking? And that's something you can figure out easily, right? Mm-hmm. How long?
Yeah, so half the barrel means that 50 liters have leaked out. And if you leak at a rate of 1 liter per hour, that means it's been leaking for 50 hours.
You see, so it's very simple. Very simple solution, right? Mm-hmm. Except, how do you know the barrel was full to start?
Yeah, so that is an assumption that had to have been made.
And it's not the only assumption. How do you know? Maybe it was full at the beginning.
Right.
Maybe it drained all the way to the end, and then it rained and refilled it. Mm-hmm. Maybe it was full at the beginning, and a circus elephant came along and drank out 50 liters in 5 minutes.
Yeah.
You have to make all kinds of assumptions here. You have to assume how much you started with. You also have to assume that everything was lost due to the leak.
Right. And You also have to assume that it was leaking at the same rate the entire time.
Exactly. Yeah. This is the part they don't tell you about radiometric dating. They don't want to tell you about the assumptions. If we look back at this radiometric decay equation, our engineer can tell you some issue here. Okay? The half-life we know, or we think we know. Okay? If we're talking about some of the half-life of like 11 billion years, nobody's sat and watched it for 11 billion years. We're trying to draw extrapolations from a very, very, very tiny tail end of the data.
Yeah.
It's very unsure. But let's assume for the moment that we know the half-life.
Yep.
And ln of 2, as I say, it's just a number.
Yep.
So the amount in the substance, well, that's what you measure in the lab.
Yep.
When they give you a sample and they say, I want to hold it, is what you measure in the lab is how much of the radioactive substance is in there now. Okay? So this is what we want to know. This is the unknown, the age. We know this.
Yep.
We can measure this.
Yeah, know the amount that we have.
Do we know the initial amount?
I don't think there's any way to know the initial amount unless you were there.
There's no way to know the initial amount. That's the problem. You see, you have one equation with two unknowns. And how do you solve one equation with two unknowns?
You can't. You need another equation.
Okay, but if you don't have another equation, what do?
You can't.
You can if you do this. You make an assumption.
Yeah, unless you make an assumption.
You make an assumption.
Yes.
And as we said, this is not the only problem, because the other problem is this is assuming all of the loss comes from radioactivity and decay. And we know that that's not the case. You can take samples of rock with radioactive materials in it, run it underwater, and leach out mother and daughter product.
Okay.
So this is very much a theoretical approach.
Yep.
And it's problematic. We see problems in it, but maybe it works anyway. How would we know? How would we test the method?
Doing experiments in the lab.
You could, but it might be problematic since we're dealing with such long time periods. You would test it basically the same way you test those climate computer models that tell us what the climate will look like 100 years from now. Okay, it's the year 2021, so the climate model will tell us what the world will look like in the year 2121, 100 years from now. How do you know if it's accurate? Well, why don't you go take the data from the year 1921, put it into your computer model, run it for 100 years, so it gives you the results for 2021, and compare it and see if it was really accurate. That's how you test the method. You test it on rocks of known age.
Right.
And see if it works.
Okay.
So and there've been many examples of doing this. Mount Ngauruhoe in New Zealand. They did radiometric dating on the lava flows there, which, once it hardens, it becomes a rock. That's your starting point. And the results showed that they're anywhere from 270,000 years old to 3.5 million years old. Okay. And the problem was the flows took place between 1949 and 1975.
Interesting.
That's a bit of a problem, isn't it? Two Hawaiian lava flows from 1800 and 1801 were radiometrically dating as being 164 million to 3 billion years old. Science, the other top scientific journal, published a result of radiocarbon dating of shells from snails that showed that they died 27,000 years ago. The problem is the snails were still alive. Antarctic Journal published results on a freshly killed seal that was radiometrically dated as having died 1,300 years ago. My favorite example. 2 samples were sent to the University of Arizona, their Department of Geosciences, the Laboratory of Isotope Geochemistry. It's one of the top radiometric dating labs in the world. That's a place where you send your samples and get them dated.
Okay.
Now, they didn't tell them what the sample was of, and they didn't tell them an estimated age. They like you to tell them an estimated age, and the result will generally come back being what you estimated. So they dated these 2 samples. Sample A, they dated it as being 9,890 years old, plus or minus 60. Sample B came out as 16,120 years old, plus or minus 220. Okay. Anyway, I hope this information is valuable to your studies. If you have any questions, please call me at, and then the numbers redact. Then they told them what these samples actually were. They were bones from an Allosaurus. You remember the Allosaurus died out 100 million years ago, something like that? See, now, if you told them these are Allosaurus bones, guess what? They would have come back telling you these are 100 million years old.
Yeah.
So much for the method. Here's another fun thing. The moon rocks. The Apollo 11 brought back moon rocks, which were dated radiometrically 116 times, using a variety of methods, including rubidium, strontium, isochron dating, and other methods. 116 times using other methods to see how well it matches up to rubidium and strontium. Out of remember, the moon is supposed to be about as old as the Earth, so 4.3 to 4.56 billion years old. That's how old it is. The evolutionists tell us, the old Earth creationists tell us, and that's what the radiometric dating will tell you. Out of the 116 dates that they came up with by radiometric dating, only 10 of them fell in that range. 106 out of the 116 didn't match what the evolutionists tell us. They ranged anywhere from 40 million up to 8.2 billion years. So that's kind of a huge range of error, isn't it? Now, of course, the ones that didn't fit, they just sat around trying to make up excuses to explain away why it didn't fit. Now, this was published, again, in the journal Science, one of the top 2 scientific journals in the world, on January 30th, 1970, in the Moon issue dedicated to the proceedings of the Apollo 11 Lunar Science Conference. And then it's quite funny. Instead of accepting the dates, and that these dates don't work, because they've decided what the date is, they try to come up with explanations why these don't match. Potassium-argon dating. Oh, it's too old. Well, it must have lost some of that argon in some other way. The uncorrected potassium-argon dates were so young that they assumed almost half, 48% of the argon was lost by a speculative impact event. Isn't that convenient? Okay, when the actual data doesn't show what you want it to show you, just the data. Any evidence that was lost? No. The only evidence is, hey, it doesn't give us the number we want. At the same time, elsewhere, where it's giving you 2 different dates than you want, they have to speculate that there was excess argon in one of the moon rocks. So much that they couldn't even calculate the date. So isn't that convenient? But it doesn't match. Oh, either has too little or too much. Well, we don't know where the too much came from, but it was there. Oh, the too little. Well, it lost some due to impact. Like, do you begin to smell a rat here? Because I do. I'm going to give you a couple of interesting quotes here. One's from Derek Ager, who is a doctrinaire evolutionist. He is actually past president of the British Paleontological Society. Okay. Highly respected scientist. And this quote, again, not from a creationist journal or a Christian source. It's a New Scientist, very popular, highly respected secular science magazine. And this guy should know, if anybody knows. And here's his quote. No paleontologist worthy of the name would ever date his fossils by the rocks in which they are found. I can think of no cases of radioactive decay being used to date fossils. Isn't that fascinating? The general public thinks, yeah, that's how they do it. That's how we know. I thought, yeah. But again, the trade secret inside is they don't do that. They know that it doesn't work. There's some more interesting quotes. This is from World Book Encyclopedia, Volume 7, page 364. Scientists determine when fossils were formed by finding the age of the rocks in which they lie. Okay, which makes sense, but then the question is, how do they find the age? Ager told us they don't use radiometric dating. Right. So how do they find the age of the rocks? Well, we read this, quote, the age of the rocks may be determined by the fossils found in them. Okay. And what's the source for that? World Book Encyclopedia, but now it's on to volume 15. So perhaps they're hoping that by the time you went through the 8 intervening volumes, you forgot. Scientists determine when fossils were formed by finding the age of the rocks in which they lie. The age of the rocks may be determined by the fossils found in them. Okay. Can you say colossal circular argument here?
Definitely.
Yeah. The only part here I can see that's true is where it says in which they lie. But they mean something very different there. Okay? So the general public is led to believe that they have these objective methods for determining the age of the earth, they really don't. It's a scam. We're back to what Professor Edward Larson said. If a people are intent in pushing out God or rejecting divine causation, this is their only alternative, is evolution, and for that they need the long ages. Mm-hmm. Let me give you another example of how these things work. And this comes from GeoTimes. And this was back in 1978. Big conference on there. And we read here, John Eadie was the world's leading solar astronomer at the time. John Eadie, opening the morning session, dropped a bombshell. It was an amazingly candid statement regarding our ability to measure the age of the sun. World's leading solar astronomer. Katzman reported it in GeoTimes.
Okay.
And this is the quote. There's no evidence, based solely on solar observations, Eddie stated, that the sun is 4.5 to 5 billion years old. I suspect, he said, that the sun is 4.5 billion years old. However, given some new and unexpected results to the contrary, and some time for frantic recalculation and theoretical readjustment, I suspect that we could live with Bishop Ussher's value for the age of the earth and the sun, which is 6,000 years.
Okay.
I don't think we have much in the way of observational evidence in astronomy to conflict with that.
Oh.
Okay. And he's the expert on that. So why does he believe it? Well, solar physics now looks to paleontology for data on solar chronology.
Really? Huh.
And the people on the paleontology, well, they look to astronomy. And back and forth, back and forth. It's like a bunch of people jumping out of an airplane without parachutes, and they're holding hands with each other. Say, I'm not going to fall because I'm holding on to you. Well, and you're not going to fall because you're holding on to him. But they're going to fall. Okay? This is the stuff that the general public doesn't know. And the flip side, something else they don't know, is that there's actually real scientific evidence to support the biblical age of the earth. It's not just Bible versus science. Mm-hmm. We've seen the supposed science that stands against the biblical timescale doesn't. And we will see that there's genuine scientific evidence that actually supports the biblical timescale of the world. So the last issue we're going to look at for now under this topic is scientific evidence for a young world. The reason that so many Christians fall into denying what the Bible says about the age of the earth is that they believe that there is a plethora of scientific evidence supporting the earth being billions of years old. There really isn't, though. We went through already some of the evidences like radiometric dating and fossils and showed that in fact they do not prove that the earth is billions of years old. Most people who believe it is do so simply because they've heard that and because they think that there's scientific evidence but really haven't looked at it. And the other reason is that the plethora of scientific evidence that the earth is young is simply not brought up. It's not presented in the schools. You actually have to go and dig for it yourself if you want to know the whole story. But there is quite a bit of such evidence.
Great. I look forward to hearing about the evidences for a young world.
All right, let's start with a very simple one, and that's carbon-14.
Okay.
Carbon-14 in the atmosphere of the Earth. Now, here's how that works. You remember when we discussed radiometric dating? Mm-hmm. The carbon-14 comes about when nitrogen-14 in the atmosphere is bombarded by particles, and it's converted into carbon-14, which is unstable and breaks down.
Okay.
Well, as an engineer, you understand how reaction kinetics works. If you start with no carbon-14 in the atmosphere and the bombardment of the solar particles will begin to build up carbon-14 in the atmosphere, but at the same time, it's also breaking down.
Right.
You get a build up, and it continues until the rate of production and the rate of destruction match, and then you've reached equilibrium.
Right.
And you will get that fixed amount in the atmosphere.
Okay.
Now, scientists have worked out the reaction kinetics for this, and they calculated that it would take 30,000 years for the ratio of carbon-14 to carbon-12 in the Earth's atmosphere to reach this equilibrium level. That is where you would get no change after that. It would stay at that level.
Okay.
And that's assuming you start with no carbon-14 initially.
I see.
If you have some carbon-14 initially, of course, then it would be less than 30,000 years to reach equilibrium. And how much less would depend on how much you started with. We talked about that in radiometric dating.
Yeah.
Now, as of 1966, the ratio of carbon-14 to carbon-12 in the atmosphere had reached only 75% of equilibrium. That's from Melvin Cook, Prehistory and Earth Models, London, Max Parrish Company, 1966. 75% of equilibrium. It would take 30,000 years to reach complete equilibrium. It would take only 10,000 years to reach 75% of equilibrium. So the amount of carbon-14 in the atmosphere is pointing very strongly to the Earth being a maximum, at least the atmosphere of the Earth being a maximum of 10,000 years old.
I see.
Have you heard that before?
I have not heard of this before.
Not surprising.
So why does carbon-14 work here exactly?
Yeah, that's a valid question. I pointed out that in radiometric dating, it doesn't work because you have to make the assumptions. Why does it work here? Well, two reasons. One, the assumption you have to make is what is the initial amount? Well,
Right.
If the initial amount is 0, that will give you the maximum age of the Earth. So that's a fair assumption to make. And as we said, if you had more, then it would be less than 30,000. So we're not calculating a specific age. We're simply pointing out what's the maximum possible.
Right.
If you pick make the assumption that would give you the oldest possible Earth, what is that? And that's 30,000 years.
I see.
In terms of the other problem with radiometric dating is how do you know that all of the mother and daughter products were put in or removed purely by radioactive decay? Again, it's not an issue here because we're talking about equilibrium, which means that all of the sources of production are matched by all of the sources of destruction. So while you can't use carbon-14 to date a specific object, you can use it to see what is the maximum possible age of the atmosphere, and it comes right into the ballpark of the biblical picture. Fits it very well, but the biblical view that the Earth is a maximum of 7,686 years old as of the year 2021 fits very well into this. The idea that the Earth is 4.6 billion years old does not fit at all.
Okay. So have people tried to explain away this model before?
You know what? I haven't heard anybody try to explain it away because it's so little known.
Sure.
You've never heard of it before. Now, they do talk about things like, well, maybe a volcano has spewed in more carbon, some form or another, into the atmosphere, and that will make... But these are local disruptions. They won't affect generally the atmosphere as a whole because the atmosphere is so huge.
Yeah.
And it would be a short-term effect anyway before it returns to normal.
Okay.
So that's one line of evidence, scientific evidence showing that the Earth fits into the biblical timescale.
Right. Yeah, so that's one of them. What other evidences do we have?
All right. Another one is short-period comets.
Okay.
Do you know what a comet is?
Yeah, so basically it's a big chunk of rock and ice in space, and you can see the tail of it, and that's because on the tail of a comet, it's ejecting a bunch of ice.
Yeah, it's actually mostly you could describe it as a dirty snowball. It's mostly ice with some little rock particles, dust in it. And these fly in gigantic orbits, and they're strongly elliptical in shape, the orbits. And they're not pure circles, they're kind of like flattened circles, ellipses.
Right.
And they have two focuses in this elliptical orbit, and they fly around it. And one focus is the sun, the other focus is out in deep space somewhere. Now, depends on how long it takes to come back around the sun, and that depends on the size of the orbit. Comets that take longer than 200 years to come back are called long-period comets, and the ones that are less than 200 years are short-period comets. Halley's Comet, for example, a very famous one that showed up in 1910 and was so bright people thought the world was going to end. That one has a period of 76 years. So
Okay.
it did come back in 1986, and we're all eagerly looking for it. Unfortunately, things are so dark and cloudy, you couldn't really see it this time.
Okay.
But that's a typical short period comet. Now, you notice as the comet flies, you see this tail behind it. And for most of its flight, actually, you don't see a tail, because what the tail is water vapor. As the comet approaches the sun, one of the focuses of its orbit, the heat of the sun begins to melt it.
I see.
And it gives off this trail of water vapor as it goes around the sun, and then as it moves back into deep space, it cools down again, no tail.
Okay.
So what happens then with this dirty snowball comet, every time it comes around the sun, some of it is vaporized, gives off that nice trail, but that means that it has lost some of its mass.
Sure. Yeah.
So a short period comet, and comets are supposed to have formed with the solar system, left over some of the material that the planets were made out of. And these short period comets, because they lose mass every time they orbit the sun, have a maximum lifespan of 10,000 years or so. There's that number again, 10,000 years. So
Interesting.
when the solar system hit 10,000 years, you should have no more short period comets. And yet they're still here. And that's, again, an indication that our solar system is less than 10,000 years old. And that's from R.A. Littleton, Mysteries of the Solar System, Oxford, Clarendon Press, 1968.
Okay. So how would evolutionists explain away this one?
Well, they get pretty desperate here. They have to start resorting to speculation and imagination. One gambit they have is to appeal to the Kuiper belt. The Kuiper belt is supposed to be this belt of planetesimals, tiny little planets, planetoids that are too small to actually be a planet.
Okay.
But supposedly there's a bunch of these out past Neptune. And the idea is that every once in a while, some kind of gravitational event knocks one of these into an orbit around the sun, so it becomes the new comet. So indeed, short period comets did burn out after 10,000 years, but you keep getting the supply of new ones. Sound reasonable?
So far, yeah. But yeah, what do you think of this?
Well, there are several problems with this idea. The first and obvious one is there's no Kuiper belt. At least we certainly have not found one.
Okay.
Right now, it's a product of evolution's desperate imagination. We have detected a few icy planetesimals beyond Neptune. And some would say that Pluto actually should count as a trans-Neptunian object.
Sure.
So we've found a few, but to keep creating short-term comets through all these years would require at least 1 billion of them. And we found, as I say, a few. And those few we found are much too large. For a comet, you should have about 10 kilometer radius to start. And these ones are ranged from 100 to 500. And other observations have created problems. They find that an awful lot of these trans-Newtonian objects are binary systems, which means as they are orbiting around the sun, they are also orbiting around each other. So like the moon orbits around the Earth as both of them are actually orbiting around the sun. And this is supposed to be a very rare thing because there's no good natural explanation for how a binary rotation system could start. But they're finding that an awful lot of these, the ones that they found anyway, they're binary systems. I can't really say an awful lot. They haven't even found an awful lot yet, but the ones they found, they're binary systems, many of them. And that means that, where's the explanation? How did this get set up? And if they get knocked into orbit around the sun, like how do they keep rotating around each other at the same time? So there's a lot of scientific problems with it, but it's also, as I said, there's no actual evidence that such a thing even exists. So that's not really an explanation.
I see.
You want another one?
Yeah, let's go for it.
Earth's magnetic field. As you probably know, you're a teacher of physics, you know that the Earth is a giant magnet. It has its own magnetic field.
Yep, that's how compasses work.
That's how compasses work. What other important function is there?
I think one large role is that it also protects the Earth from solar winds. So it protects our power grid.
Protects us too.
Yeah, it protects us, yeah, and the power grid, yeah.
Yeah. There are high energy particles coming out of space all the time, but our magnetic fields around the Earth actually deflect these, put some of them into permanent spiral orbits. It's actually very interesting. But the point, and without that, you couldn't have life on Earth, actually.
Okay.
But the interesting thing is, okay, Earth has a magnetic field around it. And the field lines go from the south magnetic pole, up to the north magnetic pole. And the interesting thing about it is the magnetic field is decaying.
Okay.
It's losing strength. It's losing intensity. And it has been decaying steadily over the past 1,000 years. We've got archaeological measurements to that effect. And here's the problem. Imagine if we've got this magnetic field around Earth, and it's been decaying 1,000 years. So what does that tell you about what happened before? Well, if it's stronger 1,000 years ago than it is now, and it's getting weaker and weaker, what was happening before that?
There had to have been some maximum.
Yeah, it had to have been stronger before, right?
Yeah.
It's a decay. And here's the problem. Magnetic fields give rise to electrical fields, which are high temperature energy fields. If the magnetic field is strong enough, the energy would just roast any kind of living thing on Earth. 10,000 years ago, this field would have been too strong for life to exist on Earth.
Oh.
We have this from Merrill and McElhinney, The Earth's Magnetic Field, London Academic Press, 1983.
Oh, that's interesting. Never heard of this before.
Well, this, as we said, the goal of science now is to drive God out. And the more you look, the more you have to ask, like, why are they not telling you these things? Is it because they want to get rid of God? As Professor Larson actually said. Larson, of course, no doubt believes what they're saying, but at least he's got it right, that this is where the theory started from, was a desire to push out God. So, where does this magnetic field come from in the first place? There's only one viable explanation that scientists have come up with. A fellow called Thomas Barnes pointed out that the only possible explanation is that there's an electric current inside the Earth. And you know that from physics that an electric field gives rise to a
magnetic field.
A moving magnetic field in turn gives rise to an electric field, and so on.
Yep.
But it has to be a moving magnetic field. This one's not moving. So what happens? The electric current is generating the magnetic field. And as the electric current gets weaker, the magnetic field gets weaker. This is why it's decaying.
Okay.
Yeah, there's no source of energy to recharge it. So if God made the Earth originally with this a good electric current inside it, that explains where the magnetic fields come from. But once he set everything in operation is going on, there's no new energy source to replenish the electric current. So electric current becomes weaker through the years, and so the magnetic field that it makes is also decaying. So as the current dies down, the induced magnetic field dies down with it. And that explains why it's being decaying. But as we see, this sets a maximum possible age on the Earth.
So based on this rate of decay, what is the estimate for the maximum age of the Earth then?
Well, we'd have to know how strong the electric current was originally to know. But it's a moot point here because, as we've mentioned, the stronger the magnetic field, the stronger the energy generated, the greater the heat. And so 10,000 years ago, you could not have had life on Earth. It was just too hot.
Right, that's true. Right.
So that's the maximum possible age.
Gotcha. So how do evolutionists deal with this one?
They have an awful lot of trouble. They have an awful lot of trouble because they know the numbers. Okay? So they have to, like, how? I mean, it's been decaying for this period, and that sets a maximum age. So what do they have to do? Well, they have to try to claim something like it flips. So it decays down a certain point, and then it flips. And then it goes up, and then it starts decaying and flips, and then starts building up. And so they, instead of just having a field that decays, they have to posit this kind of flipping back and forth.
And have we observed this flipping before?
Absolutely not. We haven't observed a flip. Now, there's certain traces in magnetic particles, iron particles, and so on in rocks that indicate that you can have like a little local reversal, certainly nothing worldwide. But there's a bigger problem to that, is if you flip and you build it back up before it decays again, where does the energy come from? Okay, this is the problem. Okay, like we said, the God created the electric current with the earth when he made it. It's no power to regenerate it. Now the evolutionists need something to regenerate it. Well, all they can say, and this shows you how desperate they get, is to say that, well, when the magnetic field is decaying, it's not actually losing energy. It's actually storing the energy in non-dipole fields. And so then it flips, and the energy goes from the non-dipole fields into the dipole fields and goes through this whole cycle over and over and over again. So in other words, energy is never lost in the magnetic field. It's always stored in some part of the magnetic field, and you go through all these years and there's no energy loss. You see a problem with that?
Yeah, that violates the second law of thermodynamics.
Exactly. The most fundamental law of science is the usable energy is always going down. You cannot have any kind of process with no energy loss.
Yeah.
And in fact, the numbers have been done comparing how much energy there is in the dipole part of the field to the non-dipole field, using data from the International Geomagnetic Reference Field, data collected between 1970 and 2000. The dipole part of the field steadily lost 235 billion megajoules of energy, while the non-dipole part was gaining, but only gaining about 129 billion megajoules.
Right, so you still have a bunch that was being lost.
Exactly. Over the 30-year period, you're getting a huge loss.
Yeah.
So at that rate of loss, that's like 1.41%, plus or minus.
Yeah.
At that rate, the field would lose half its energy every 1,465 years, plus or minus.
Okay.
So that means that the attempt to explain this away from the evolution, it just doesn't work. And we knew it wouldn't, because it violates the second law of thermodynamics, the most fundamental law of science. So we're back to the fact that the evidence tells us that the magnetic field around Earth would have been too strong 10,000 years ago for life to exist on Earth, which again, it tells us at least life on Earth has to be less than 10,000 years.
I see.
And they have no good gambit to get around that.
Interesting. What else is there, John?
Well, there's the rings of Saturn. And I'm sure you're familiar with the rings of Saturn. You've seen them. They look so pretty, right? Actually, a number of planets have rings. They're just too small relative for us to see them. Saturn's got the nicest, biggest, most beautiful rings.
I see.
And scientists used to think that they didn't even know what it was. It might be a gas, it might be some kind of liquid. It's all uniform, and some that just kind of equalized through the billions of years. So it's just kind of a homogeneous structure around the planet. Well, we got satellites up there and saw this is actually not the case. They're made up of tiny little pieces of rock.
Okay.
And these rings of rocks are being continuously pummeled by little meteoroids. And they're breaking up the rings. And they're breaking them up at such a pace that these rings should have completely dispersed within 10,000 years. Yet they're still there.
I see.
And that's from Jeffrey Coetzee, Ring Planet, Still Mysterious 2, Sky and Telescope, Volume 69, January 1985. So it's still mysterious, they say. They don't understand why. And the reason they don't understand why is because they don't want to admit that the universe cannot be more than 10,000 years old. And it gets worse with the other planets. Like once they sent the space probes out there around Jupiter and Saturn and Uranus, with Jupiter, they took the measurements. They said that the particles should only last a very short time, perhaps only a few thousand years.
I see.
And yet they're there. For Uranus, they said they concluded this: the thin outer atmosphere of Uranus extends into the rings, so it should slow down very tiny dust particles and cause them to sink into the inner atmosphere in a few thousand years or less.
So even all the outer planets, all of this evidence points towards just a few thousand years.
Yes, exactly. But again, you don't hear this. You have to go looking for it yourself.
How do evolutionists explain away this one? I imagine it's pretty hard because most of these outer planets are saying a few thousand. So how do they explain away all of these planets?
Yeah, they had different attempts, explanation, and observation debunked them all. The current one that they're holding on to is shepherd moons. They say.
Shepherd moons.
Shepherd
Okay.
moons. The moons of the planet kind of act as shepherds to keep the rings in place.
Oh.
But the problem is that doesn't work either. It's interesting. You send out some probes and you look for moons. One of Saturn's moons called Prometheus. They went looking for it, and they know where it is, where it's located. They didn't find it where they were looking. They found that Prometheus had actually slipped in its orbits by 20 degrees because it collided with some of the objects in one of the rings of Saturn.
Okay.
I think it was in early 1993. Mm-hmm. But they're finding what the moons are doing is actually interacting with the rings. They're not standing back and shepherding them, actually colliding with them and likely disintegrating as a result. So this is, I think, why Jeffrey Coetzee says, like, this is still mysterious. They have no explanation. They have none.
I see.
And here's what you have to start asking. Science is supposed to go where the evidence leads.
Right.
So if the evidence is telling you from one source after another, that the Earth cannot be more than 10,000 years old, why are they still holding to the billions of years? And there's more. We talked about this one already before, about the blood vessels, soft tissues.
Right.
In fossils that are supposed to be, well, we looked at the T-Rex that was 65 million years old. They found it in older dinosaurs. But here's an even more fun one. And that is, this was published in the year 2000, Vreeland, Rosenzweig, and Powers in Nature. Remember, one of the top two journals,
yes.
Nature, Volume 407, titled The Isolation of a 250 million year old halo-tolerant bacterium from a primary salt crystal. In other words, they supposedly found bacteria, they called it the Lazarus bacteria because it's coming back from the dead, inside a salt crystal, which they dated as being 250 million years old, and they brought it back. It's functioning.
Huh.
Now, even the evolutionists, we looked at specific numbers earlier, but they agree. Even the most ardent evolutionist agrees that bacterial DNA, okay, it's an unstable molecule, breaks down quickly, shouldn't last more than 1 million years. And yet here we're told that this bacteria, that's 250 million years old, can be revived.
Yeah.
And its DNA is very, very similar to modern bacterial DNA. You would think that if this bacteria here was locked inside the salt crystal 250 million years ago, and the other bacteria have been evolving for 250 million years, you should see some significant differences.
Huh. Yeah.
But you don't.
I see.
And once again, like, these people with a straight face can say, yep, bacterial DNA cannot last more than 1 million years. Yes, this bacteria is 250 million years old. What's the Bible say about double-minded men? Unstable in all their ways.
Well, are there even more than this?
Oh, yes.
Wow.
I think you'll appreciate this one as an engineer. And this has to do with zircon crystals.
Okay.
These particular zircon crystals, when they're formed, they contain trace uranium.
Okay.
And the uranium, as you know, undergoes decay and gives off helium as a byproduct, alpha decay. So experiments were done on these zircon crystals that were pulled up from Precambrian basement rock in New Mexico.
Okay.
And this, we're told, is 1.5 billion years old. And here's the problem. Uranium, trace amounts of uranium, decay to helium. Helium is very small. Right?
Yeah.
It's just
It's only
two
the second one
protons,
in the periodic table.
2 protons, 2 neutrons. And because it's very small, it slips out through the lattice structure very, very easily. Dissipates, diffuses out of the crystal. So if it's 1.5 billion years old, you shouldn't find any helium in it. But when they analyzed these crystals, they found that 58% of the radiogenic helium was still there. Okay, so that's the observation. So a very interesting thing was set up by, it's called the RATE project, I believe. And this is how real science is done. Okay, they took the data they had, 58% of the radiogenic helium is still there, and they graphed, did a diffusivity graph, how much helium would diffuse out of the crystal per unit time. And they did two curves. One is, okay, let's assume this crystal is 1.5 billion years old. And they did the curve, what the curve would look like. We do another curve if it's 6,000 years old. So you have two different curves. Okay? And the one for, if it's 1.5 billion years old, then the diffusivity obviously is a lot lower. It's down in the order of almost 10 to the minus 23 square centimeters per second. If it's only 6,000 years old, it's much faster, down around 10 to the minus 18 square centimeters per second.
Yep.
It's the diffusivity. So once you've applied these two curves, then you take your data. You do get labs to do experiments on how fast helium diffuses under different conditions of temperature and pressure and so on. Then you add that data to this graph and see which one it lines up with.
Right, yeah.
And here's the result. Which one did it line up with?
Well, very, very closely to the 6,000 year plot. Yeah.
So this is how real science is done.
Huh.
This is smoking gun. When the laboratory, like a secular laboratory was commissioned to do the analysis of this, they weren't told what the purpose is. They did their work. They did it right. This are the results. When they found out that this is what it's for, that the data supports that the Earth is 6,000 years old, not 1.5 billion, they were angry.
Oh, yeah?
Hey, screw you tricked us. You shouldn't do that. And so it's wrong then? No, that's what the data shows. I mean, we did our work right. We're just angry that it's being used for this. I'm not sure why you should be angry if the data is being used to show that the Earth is, roughly 6,000 years old. And that's what science is supposed to be about, isn't it? Follow the evidence where it leads? Well, it hasn't been about that for a very long time, unfortunately.
I see. This reminds me of the radiometric dating of the bone samples that also showed that the ages of the bone samples were a lot younger.
Oh, yeah. They weren't happy about that either, but they had to stand by the quality of their work.
Okay. Is there even more?
There is indeed. We're back to carbon-14 again.
Okay.
And once again, we're not giving specific dates, as they try to do with carbon dating. We're simply pointing out maximum possibilities.
Okay.
Now, the half-life, we've mentioned this before, the half-life of carbon-14 is only 5,730 years. Okay. And some radioactive substances that are like partial seconds. So to them, this is pretty old, but other ones are in the order of billions of years.
Okay.
So the half-life is 5,730 years, and you remember half-life means that in that period of time, half of it decays away. So after the next half-life, two half-lives, half of the half has gone, so you're left with a quarter. After another half-life, you're left with an eighth.
Yep.
After 10 half-lives, and less than 1/1000th is left.
Okay.
What that means is if you took a lump of pure carbon-14, as massive as the Earth itself, it would all have decayed away in less than 1 million years. You'd have none left. Less than 1 million years. Okay. So and that's if you start with a sample the size of the Earth.
Right.
We're looking at carbon-14 in fossils.
Yeah.
That's much less than the size of the Earth. It'd be a lot faster. So certainly, if a sample were really over 1 million years old, you'd have no carbon-14 left in it all, no radiocarbon. That's not what we find. Coal, for example, which supposedly formed all these tens of millions of years ago, all over the world, wherever you get it from, it has carbon-14 in it, which means that these are well less than 1 million years. Oh, much less. They were thousands of years old at most.
How do evolutionists explain this one?
Oh, well, they will go to the dodge of contamination. Contamination, you see, it's the carbon-14 wasn't really in the fossil. That the stupid researcher actually contaminated the sample. He put some carbon-14 on it from his own body or from the atmosphere or whatever. And you can find every single coal sample from every single field in the world, doesn't matter. Contamination. Where's your proof that's contamination? Well, they can't prove it. They just assume it because it has to be. Because we know these coal samples must be hundreds of millions of years old or tens of millions of years old. So it has to be contamination. Now, they can be handle this as well as possible, and they'll still insist it's contamination, which should call the whole method into question, but it never does. You see, it's always the double standard. We champion it when we can use it to support our view. When it debunks our view, then we attack it. But that's what they do. It's all contamination, but they get checkmated eventually with diamonds. What do we know about diamonds?
They're one of the hardest substances on Earth. They're made of carbon.
The hardest?
The hardest.
Actually, you're right the first time as well.
Oh, okay.
For a very, very long time, it was the hardest substance known.
I see.
It was so hard that when rocks are graded in minerals, on what's called Mohs hardness scale, and they go 1 to 10, and the hardest would be diamond number 1, and second is corundum, and then you get down to number 10, it's talc.
Right, very crumbly,
Very crumbly. But the difference in hardness between diamond number 1 and corundum number 2 is actually bigger than the difference between corundum number 2 and talc number 10.
Wow.
It's such a strong, rigid structure, diamonds do.
Yep.
They've actually, within the last, I think, 10 or 15 years, discovered a new form of carbon called graphene, which is actually harder than diamond, but that's a very new discovery.
Yeah, there's lots of engineering hope that people are putting into graphene. But anyways.
Be careful. Apparently it flakes kind of like asbestos, not to the same extent, but it does. So when people use it in masks, for example, you may as well be breathing in asbestos. So it's hard. And here's the problem. How do you contaminate a diamond? To contaminate a diamond with carbon-14, you would actually have to knock one of the carbon-12 atoms out of its structure and replace it. But how do you do that when it's the hardest substance there is?
I have no idea. Can't
be done. So you can claim it for coal or graphite. You cannot do it with diamonds. Okay? It's very resistant to contamination. Now, according to evolutionists, the diamonds formed 1 to 3 billion years ago. A geophysicist named Dr. John Baumgartner, part of this rate research group, investigated carbon-14 in a number of diamonds. And remember, there should be no carbon-14 at all if they really were over 1 billion years old. But the radiocarbon lab reported that there was over 10 times the detection limit.
I see.
So actually much less than 1 million years old. And Baumgartner went ahead and repeated this with 6 more alluvial diamonds from Namibia. All of these had even more radiocarbon in it. So here you go, folks. There is hard scientific evidence, a lot of different areas, a lot of different ways to prove that the Earth is of an age consistent with the biblical timeline, a maximum of 7,686 years. You're told that there's overwhelming scientific evidence that the Earth is so old. We have so many different ways to know. We really don't. There's this very, very few things they appeal to try to prove it. And all of them, as we've seen, are problematic, seriously problematic. There's only one left, really, one issue to look at on this. And this, unfortunately, is the one that has managed to convince a lot of Christians to abandon the biblical timeline. And that is hugely problematic. Do you know what this issue would be?
About stars and the age of the stars in our universe?
Exactly.
Okay.
The stars, the starlight problem.
Okay.
And it goes like this. Okay? And this will be the most common objection you will encounter to the age of the young universe.
Okay.
We know how far stars are away from Earth. We know how fast light travels.
Right, yep.
3.0 times 10 to the 8 meters per second.
Yep.
We know how, and that's the maximum speed. Light cannot move faster than that.
Yeah, that's the speed in a vacuum, yes.
Yes. So we know, since we can see the star, so the light must have gotten to us all the way from that star at that speed. And if the star is billions of light years away, then the light must have traveled billions of years. And so the world must be billions of years old. Have you heard that objection before?
I haven't heard of it before, but it makes sense assuming that these distances are correctly measured.
Assuming that the distances are correctly measured, that's true. That's an interesting discussion. But before we even get into that, let me point out something else that people may not know.
Okay.
And that is, this is assuming light can and has always and only travels at that maximum speed. The Big Bang Theory, the one that scientists tell us this is the scientific view, has the very same problem a light travel time problem. And the problem basically goes like this. The temperature throughout the entire background of the universe, okay, we use the COBE satellites to come with those measurements in 1992. COBE, so COBE for Cosmic Background Explorer satellite, and brought in the best data we had so far on the temperature of the Earth. And they found that the universe, if we look, it's isothermal. It's the same temperature everywhere. Now, again, you know from physics about heat transfer, right? When heat moves, where does it move from and where does it move to?
Yeah, it moves from the hotter end to the lower end.
Exactly. It always moves from hotter to colder.
Yes.
And we'll keep doing that until the temperature equalizes.
Yeah.
Okay? And the only way you can go against that is with artificially with a heat pump or something like that. But naturally, heat always moves from hotter to colder. So the hotter object becomes colder, the colder object becomes hotter until they match, and they get no more heat transfer. That's actually the heat death of the universe we're heading towards. But here's the thing. The temperature, everywhere you look in the universe, no matter how far out, it's all about equal. And the only way that could have happened is for the radiation to have traveled from the hotter spots to the colder spots until everything reaches equilibrium.
Yeah, that sounds right.
But because it's equilibrium everywhere, you would have to have light traveling from one end of the cosmos all the way to the other to do the equalization. And heat cannot move faster than light.
Yeah.
And supposedly, science has proven the universe is 13.6 billion years old. That's the Big Bang timescale. But the spread of the universe is 93 billion light years. So how do you cross 93 billion light years of distance in 13.6 billion years?
I have no clue.
We can't unless light has gotten from point A to point B faster than the speed of light alone allows. So we may not know the mechanism of how it can happen, but it has to happen regardless of whether you take the biblical model or the Big Bang model. Okay? Now, they never want this called the horizon problem. They never want to talk about that. They want to go after the biblical model and say, oh, look, light can't have traveled faster than the speed of light. Your model must be wrong. They don't mention that you have the same problem with their model. Okay, that's okay. And yet, so many Christians jump all over the Big Bang bandwagon. Not sure why.
Okay. We
can also point out, by the way, in passing, that it's impossible to measure the one-way speed of light. We don't know.
Yeah, that is true.
Can you elaborate on that?
Yeah, because the way that we're measuring the speed of light right now is that we have to shoot a beam of light into a mirror and have that reflect back. So that's the only way that we can measure the speed of light, because we need a point in space where we can start and stop this experiment. And that is not possible to do if we were to just set up a one-way experiment to measure the speed of light.
Exactly. Very good. So yeah, you cannot measure. Every measurement we've ever done of the speed of light is always two-way.
Yep.
It's the time to get there and then the time to bounce back. Okay? And then we calculate the maximum speed of light by dividing that by 2, basically, assuming that it goes at the same speed both ways. But we don't know that.
Yeah, we don't.
There are asymmetries in the universe, like the matter-antimatter, for example. Well, this matter, and where's the antimatter? So there are asymmetries. It's entirely possible that the light coming here from the stars is moving at essentially instantaneously or near instantaneously. And then when it hits something and bounces back, it moves at half the speed of light that we measure.
Possibly, yeah.
Yeah, so we don't know for sure. Yeah. When we say that the light is coming from the stars to us at 3.0 times 10 to the 8 meters per second, maybe, but we don't know that. Right. Maybe it's reaching us instantaneously and we're seeing what's out there exactly as it's happening. That is a possibility.
Okay.
So that's to set the stage and to point out that this, if this is a problem for us, it's certainly a problem for them.
I see.
So what are the possible explanations there? Well, one of them is that the speed of light may not have been constant throughout history. It may have been faster in the past. There's a lot of resistance to that idea because of Einstein's theory of relativity, which makes speed of light the fastest possible speed it can have, 2.9997 meters per second. It's the maximum possible. Now, that's a theory. It's a thought experiment. It's supposed to be supported by some experimental results, cast doubt on by some other experimental results. But as far as I know, it's constant with respect to space, not necessarily with respect to time. Like the maximum speed might have been different in the past. And certainly there's some observational evidence that supports that idea. Some years back, for example, this cover of Science, Discover magazine, cover articles, was Einstein wrong about the speed of light? And that, I think, was the April 2003 issue. And what was found, why this became an issue, is observations done by a team of scientists, Australian scientists, and they were studying specifically on the data collected by a fellow called John Webb, astronomer at the University of New South Wales. And he was studying the light from a distant quasar. Quasar is a star-like object. And he found that it had absorbed the wrong type of photons from interstellar clouds. And that's a problem. If you don't understand full details, the problem is that the atoms emitting quasar light were slightly, but ever so significantly different from the structure of atoms in humans, the atoms we know. Now, how do you explain that? Well, there's only two possible ways to explain it, they said. Either the electron charge has changed, or the speed of light has changed. And two cherished laws of science, they point out, is that the electron charge cannot change and the speed of light cannot change. So on one of those, they are wrong. So which one? Which one is wrong here? And what they found, what he said, is that so either the electron charge has changed or the speed of light has changed, but the laws of science that the electron charge cannot change and the speed of light cannot change. As a theoretical physicist, Paul Davies, who was leading the team of Australian scientists, he said, whichever way you look at it, we're in trouble.
Yeah.
So he's trying to look at like which of these two constants may actually not be constant.
Huh. Yeah.
So they looked at studies of black holes. They applied the second law of thermodynamics, which basically says you can't get something from nothing. You remember that? The Moser law of science. And they say, after considering that a change in the electron charge over time would violate the second law of thermodynamics, the one thing you can't do in science, they concluded the only option was to challenge the constancy of the speed of light.
Interesting.
So speed of light may not be constant as we thought.
I see.
So that's one possibility. Now, the change is not huge. Okay? It's a very small change from this particular observational evidence, but it is a change. Some 0.001% or something like that. More recently, they found conditions where the speed of light can be 300 times the supposed maximum speed.
300 times?
300 times.
Whoa.
Yes, published in optics.org and other sources, and this is from the year 2002. The headline is, Laser Pulse Travels 300 Times Faster Than Light. Scientists at NEC Corporation's Basic Research Unit claim to have proven that light can travel faster than its acknowledged speed in vacuum in a successful experiment in superluminal light propagation. They had it move more than 300 times the speed of light. Okay, then they claimed this unusual phenomenon is a result of anomalous dispersion. They say it's an effect not seen in nature in transparent materials, and it's created by the non-natural thermal state of the cesium gas used in the chamber. But here's the thing: it proves that the speed of light is not limited to the 3.0 times 10 to the 8 meters per second. It can be faster. In this case, 300 times faster.
That's crazy.
Now, they'll say that, oh, well, it can't happen in nature. Well, you don't know. We haven't looked everywhere in nature. But even it couldn't. If it requires special conditions, well, remember, we're talking about a creator God. Creator God is quite able to make special conditions.
Yeah.
And then in the creation week, there's no reason to think that he wasn't doing that.
And even thinking about stars. Stars themselves have all types of crazy conditions inside of them.
So. Yeah. So that's one possible explanation, that perhaps the speed of light was faster in the past, and we're not actually limited to the supposed maximum speed.
Okay.
Another explanation, and this is popular among certain apologists, certain creationists. D. Russell Humphreys worked out one model. I think John Hartnett worked out another. And they based their model on the theory of relativity. As I read it, it comes down basically as saying that God created the world 6,000 years ago and 13.6 billion years ago. All depends how you measure it from. It's all relative.
Okay.
If you happen to be sitting on Earth, yeah, it was 6,000 years ago. If you're in the universe, it's 13.6 billion years. Somewhere else in the universe, there'll be some other number. There's some creationists who like that model. I don't like it at all. At the end of the day, it's not really true then that God created the world 6,000 years ago. God created the world, and how long ago was all depends on where you're looking from.
Huh.
So, and I don't think it's necessary to do that. Okay. I think there's a much better explanation than the one that I actually hold to. And that's this. Let's remember, this was an act of miracles.
That is
Creation is miracles.
Mm-hmm.
Okay? And the entire creation week involves miracles.
Yeah.
Now, some Christians say, well, you shouldn't have to appeal to miracles unless, you have to appeal to miracles. Everywhere else it should be natural. I'm not sure why, when God is doing a week of creative miracles, why we have to try to make every part naturalistic where we can. It almost seems to me like a reverse of the God of the gaps. Actually, it's not a reversal. It is a form of God of the gaps. But the thing is, he made the world in 6 Earth rotation days, 24-hour days. And the laws of physics that then operate after that didn't hold until he finished his creation. And certainly he can violate any law at any point he wants. That's what a miracle is. This is why Jesus could turn water, just hydrogen and oxygen, into wine, which has the carbon and other substances in it.
Yeah.
And it should be obvious. It really should. The most fundamental law of physics, fundamental laws are the laws of thermodynamics, the law of conservation of matter and energy, which says that matter and energy cannot be created or destroyed. Mm-hmm. What's the very first act God did in the creation week?
He created.
Yeah.
Yeah.
In the beginning, God created the heavens and the earth. So he brought into being matter, energy, which hadn't existed before. Mm-hmm. Ex nihilo, we call it, out of nothing.
Yeah.
Now, I wonder why, if an atheist will point to a creation account and say to a creationist, oh, see, this is scientifically wrong. It says God created matter, energy, but we know from the first law of thermodynamics that can't happen. And I don't see why creationists don't follow themselves saying, oh, yeah, that's a big problem. We have to come up with some kind of plausible, naturalistic explanation. No, you don't. You don't do that. You say it's a miracle because that's what it is.
Mm-hmm. And they're facing the same problem.
Yeah, this is a miracle.
Yeah.
And yet somehow when it comes to starlight, they forget that. And say, oh, we have to find some kind of explanation that fits in with naturalism. Mm-hmm. Okay? Sorry. No. These laws apply to all naturalistic processes. They do not apply to God's creative acts or any of his miracles. The laws govern the operation of God's created world. They don't govern God's own actions. Mm-hmm. Now, so that means that when God finished creating, reached the end of day 6,
yep.
It's a fully formed, mature creation. All of the beams of starlight are already in place between the stars and the earth.
Yep.
And maybe he did it by making the light move super speed from the stars to the earth, and that can do that. God can do that. Mm-hmm. So we say, oh, well, it would have changed this and that and the other thing. No. If it happened now and something made the speed of light move up, yeah, a lot of changes. But not in the week when God is making the world. Now, is God not able to keep the other parameters under control while he speeds light? Yes, he can. Now, some people would object and say that this makes God look deceptive because he makes the world look older than it is. But that's actually a bogus objection. We judge age by comparison with known phenomena. Creation is a unique event. We have no basis for comparison. And if you look at a person and ask how old do you think he is, and you say, oh, I think he's about 30, or a child, you say, oh, I think he's about 7. Mm-hmm. Well, how? Because you've seen 7-year-olds. You know what 7-year-olds look like. You've seen 30-year-olds. You know what they look like. Uh-huh. So you look at this guy, and you think, okay, where does he fit in comparison to the people I've seen?
Sure.
But we say the world looks old. what's that based on? What other world did you compare it to? Have you seen the growth processes of worlds before?
I see.
What they really mean is, if we take some unwarranted presuppositions and add to that some indirect inferences based on unwarranted presuppositions and reach a conclusion that differs from what the Bible says, the Bible must be wrong. And I don't know, that does not make sense to me. If you showed up like 1 minute after Adam was created, for example, out of the dust of the earth, adult, presumably had few skull sutures, epiphyses, he was maybe 6 feet tall. Now, if you saw somebody like that today, you would say, well, it's got to be about, 26.
Right, sure.
But we know he was like a minute old at that point.
Yeah.
And so, it's deceptive, God, you made him look 26. Well, okay, you only think he looks 26 because you're comparing him to people who went through natural life cycles, which Adam didn't. And it's especially not deceptive because he told you, right? He told you when he made Adam. How's that deceptive? There's something published on the Creation Ministries International website that they call the Parable of the Candle. And I don't remember all the details, but it goes kind of like this. A couple of young people go into a room. They're expecting to meet their friend there. They find instead that a note. There's a note left by their friend, and the friend says, it's 2 p.m. now. I'm leaving. I should be back in an hour or so. And I've left this candle here for you to give light. And there's a candle, and it's burning. And one person says, I wonder when our friend will be back. The other one says, well, he told us. He left at 2, will be back at 4. I said, whoa, but wait a minute. Look at this candle. We can measure how long, okay, when you light it and it's burning, how much wax is burned per unit time. So how much of the candle's length will be lost every hour. And we look at this and see, look at that. It's been dripping for this long. He must have been gone for at least a day. Okay, so we don't know he's coming back because we don't know when he started it. And the friend comes back at 4, like he said.
Yep.
And this person who made those calculations starts complaining to him and says, look, you deceived us. You said you left at 2, you said you come back 4, but we measured the candle, the rate of drip and so on, and we know that you didn't really go to. And he says, look, first of all, that candle was not a new candle when I put it up. It was already used. Most of that length was already gone. Second, how did I deceive you? I told you flat out in propositional statements when I left and when I'd come back. Why would you think that your indirect inferences based on assumptions about the candle is somehow more reliable than my propositional statements? But that's what it's come down to with these Christians who accept that the earth is 4.6 billion years old, the so-called old earth creationists, or theistic evolutionists also. They believe these indirect inferences based on unwarranted assumptions. And so when that contradicts the Word of God, which is the one they hold on to, and which is the one they discard? Let's return to the horizon problem.
Okay.
According to the Big Bang Theory, let me say, that's what I accept. I accept that this miracle, I don't see a problem with starlight travel any more than I see a problem with creating out of nothing or organizing what that matter energy created, organizing it into planets and stars and solar systems and so on, all of that order we see, which again, of course, second law of thermodynamics kind of happened.
Right, yeah.
They're miracles.
Yeah.
Okay, we accept miracles. I don't understand Christians who have no problem accepting the miracle of resurrection, but creation, no. There we have to go with what secular science claims. Makes no sense to me. So, if we go back now to the horizon problem of the universe, according to the Big Bang Theory, the universe expanded from a diameter of 10 to the minus 30 meters to 1 meter in the first 10 to the minus 30 seconds, which means that light must have been moving at a speed 6.67 times 10 to the 21 times the maximum speed of light. Wow. 10 to the 21, we're talking about, let's see, that would be a million times a million times a billion. Okay, that's a lot faster than the maximum speed of light. So how do they explain that? You see the getting from point A to point wasn't all done just by the movement of the light itself. It was done by the stretching of the entire universe. Okay? So that the two factors add together to move the two things apart. Stretching universe. Well, it's interesting. What do you read in Isaiah 42:5?
Yeah, Isaiah 42:5 says, "Thus saith God the Lord, he that created the heavens and stretched them out."
Stretch them out. Now, that's actually interesting because why primitive people making up an origin myth, why would they imagine that God stretched out the heavens? And yet we see that throughout the Bible. We see that again and again and again, that God stretched out the heavens.
Mm-hmm.
So, Isaiah 42:5, we saw that. Isaiah 45:12, I've made the earth and created man on it. My hand stretched out the heavens and all their hosts I have commanded. Isaiah 48:13, indeed, my hand has laid the foundation of the earth, and my right hand has stretched out the heavens. When I call to them, they stand up together. Isaiah 51:13, and you forget the Lord your Maker, who stretched out the heavens and laid the foundation of the earth. Jeremiah 10:12, he has made the earth by his power, he has established the world by his wisdom, and has stretched out the heavens at his discretion. Okay? So when the Big Bang people run into trouble because they need light moving from point A to point B faster than it supposedly can do, well, they have to add in the stretching. Yeah. Now it's completely ad hoc on their part. We'll just have it stretch out. Problem solved. And yet here, written thousands of years earlier, the Bible already has God stretching out the heavens.
Yeah, that's so cool.
And again, why would ancient peoples imagine that God had to stretch them out? But if this is how light got from point A to point B faster than the speed of light, well, it's already there in the Bible thousands of years earlier than the Big Bang Theory invented it. And here's the question. Again, the Christians who hitch their apologetics wagons to the Big Bang Theory have no problem accepting this for the secular theory. But you mention it for the Bible? Oh, no. No, we don't accept that. So the reality is God put the stars in their current places almost instantly after their creation. Okay? And he stretched out the heavens as he wanted. And now, okay, we can't measure how fast that was. There's no residual effect. But now, after he's created the whole world and everything is finished and the stars may be drifting away from us, that's all we can measure is the current rate of residual expansion, their inertial drift rate. And then if we extrapolate from what it's doing now and assume it was always doing that, then we get a very wrong answer. Well, in point of fact, it's only the maximum 7,686 years that we've had this rate drift expansion.
I see.
So you begin to see, I think, that there's so very many problems with the Big Bang Theory and with secular attempts. They keep trying to plug holes with the Big Bang Theory. And their theory is the universe started out as a singularity. One tiny little ball, or whatever you want to call it, so small, it's smaller than the head of a pin, and yet all of the matter, energy of the entire universe, was contained in this tiny little ball. Where did the ball come from? They can't tell you. It's just there. I think we talked about this before, that you can't have something in the universe just eternally existing. And you can't have something coming out of nothing. So where does that come from? And you'll sometimes find the atheists saying, well, we don't know, but it doesn't matter that we don't know yet. Eventually we'll figure it out. And you'll find them appealing to this a lot of times, saying, we don't know yet. Okay? But the problem here is not what we don't know, it's what we do know. We've already discovered the laws of science that tell you this can't have happened. So you can say, we don't know yet, you can keep looking if you want, but science has already told you this model is not going to work. Okay? So that's what you start with, and then at some point, you get a big bang, you get a big explosion. Now, they like to say that you shouldn't call it an explosion, you shouldn't call it a big bang, it really isn't a big bang. It's a sudden expansion. Okay, we won't call it a bang, we'll call it a sudden expansion. Same problem. What makes it suddenly expand? Well, we don't know. It just did. A miracle, perhaps? Oh, no. You can't have miracles because we don't have God there. It just did. So it sounds like a miracle. No, it just did. Okay, so it just starts expanding, and what happens was as it expands, it begins to cool down. As it cools down, these really fast-moving things start to coalesce into subatomic particles, and then into atoms, and so on. And then eventually, these atoms join together and give you different kinds of atoms, different kinds of substances, mostly hydrogen, and then heavier ones, helium and lithium. And they get a bit of problem with how do you get heavier elements in that? Well, you just do. Okay? Maybe they formed in stars. Where the stars come from? Well, they just formed. And yeah, they'll have stories, but the stories don't fit science. How? If you have subatomic particles, and you got the sun expansion, you got these subatomic particles or precursors to subatomic particles, and they're moving away randomly in every conceivable direction, and they're really super high speed.
Yeah.
How do they join together? What would make them join together? Because if you get, like, say, solar system, you need a star in the center. You need planets. You need centripetal motion, centripetal acceleration. You need to set up this particular type of motion. How do you get that when all you have is like subatomic particles flying away in every direction? What brings them together? Yeah, well, I asked, this fellow was a so-called old Earth creationist. He's also a physics professor.
Okay.
I asked him about it. What makes it happen? He said gravity. Gravity? Yeah, gravity. They have masses, they're very small, but gravity will pull them together. I said, no, that's not enough force. You imagine, force of gravity is G times M1, M2 over R squared. And imagine what's the R. Imagine what those tiny, tiny M's are.
Yeah.
That's not enough force. Okay? Just think of inertia. I mean, these things are flying in this direction. Is that enough force to change the direction? No.
Right.
He said, yep, doesn't matter how small they are. Gravity made them pull together. Really? Yeah, gravity. And gravity then accretes them into these big balls, and something happens to make them have centripetal motion. So you really think so? Gravity did it. Yep, gravity. And I asked him this question, how old is the Earth's atmosphere? Well, it's about as old as the Earth. Just almost as old as the Earth itself. Okay. So we're talking like 4 billion years? Sure. What's in the Earth's atmosphere? You know what's in the Earth's atmosphere, right?
Well, oxygen, nitrogen, mostly nitrogen.
Yeah, about 80% nitrogen.
Yeah.
N2.
Yeah.
Oxygen.
Yeah.
O2. What's the atomic mass of oxygen?
16 grams per mole.
Technically 15.994, but say 16, so 32 for an oxygen molecule, O2.
Yeah.
And I said, okay, now, so here's these oxygen and nitrogen molecules in the atmosphere of the Earth. How heavy is the Earth?
Very heavy.
Well, yeah. So if you imagine the gravitational force between an oxygen molecule and the Earth, how would that compare to the gravitational force between two subatomic particles?
It's much, much larger.
Yeah, orders of magnitude larger. I remember I did the calculation once, it was something like 10 to the 57 times larger.
Okay.
And I said, okay, so you have this force. It's 10 to the 57 times larger. Again, what's 10 to the 57? A billion times a billion times a billion times. Yeah. How come, Professor, that in the 4 billion years, these oxygen molecules have not all accreted to the surface of the Earth? Because, the gravitational force between them and subatomic particles is far, far greater. Billions times billions times billions times billions times billions times billion times greater. Why didn't it do it? And he went absolutely silent. He had no answer. It's like he never even thought about this. They just say it. And this is the problem. They don't think it through. They say, oh, gravity. Yeah, sure, gravity attracts. So, yeah, gravity did it. And they don't crunch the numbers. They don't see, is this reasonable? And they don't look at what we see around us. If gravity could do that, then certainly all the atmosphere of the Earth would have been accreted to the surface of the Earth billions of years ago. But it isn't. So this idea that of the Big Bang, where you have all these subatomic particles forming and then coming together, it's a scientifically a non-starter. You can't even, it won't even get to square one. And then, but they have to hold to this because they need some way to get God out. And what becomes really funny is like and the theory is already impossible, but then you look at the evidence for the impossible,
Okay.
and you will begin to see what a farce it really ends up being. They actually have the top three facts, evidence for the Big Bang. They point to number one, the so-called background radiation, the cosmic background radiation. And they say, well, where did this radiation come from? It fills the universe uniformly. They'll tell you there's the super cooled afterglow from the original Big Bang. Sound reasonable?
I'm not sure what that means.
Well, where's this radiation? Because you have this big burst of energy with this expansion. And so that burst of energy left this track because it's cooling, but it's not all gone.
Okay.
So you have that background heat, basically. And the temperature universe is not zero, it's above zero. And that's where it came from. It's a supercooled afterglow from the original Big Bang. Okay? That's evidence number one. Is it, though? Microwave background radiation proves that there's cosmic microwave background radiation. It doesn't prove that it's the supercooled afterglow from the original Big Bang.
Right.
Before the Big Bang model was even invented, there were scientists who said, look, you have stars in the universe. Stars give off heat.
Yeah.
So you're going to get a certain minimum background radiation. So just having background radiation is not the supercooled afterglow from the original Big Bang. That's an assumption. They're basically jerry-rigging it into their model, but it doesn't actually prove it.
Okay.
Any evidence that can be legitimately interpreted more than one way, it's not evidence for anything, right?
Right.
If I have like three suspects for the killers, and I find that the killer was left-handed, and Tom there's left-handed, it proves he's a killer, right?
No, not necessarily.
Well, especially now if Dick is also left-handed and Harry is also left-handed.
Right.
So here's the problem. The cosmic background radiation only shows that there's cosmic background radiation. There's no evidentiary basis for saying it as the supercooled afterglow from the original Big Bang. So that actually is not evidence.
Okay.
The second one, and this was the biggie, was that the universe is expanding. It tells that galaxies outside the Milky Way move away from us at a rate proportional to their distance from us, pointing to continual expansion from a single source. And we'll look at that in detail later.
Okay.
And the third evidence that they will give you is the Big Bang nucleosynthesis. And what this is, where do you get the heavy elements? Okay, that was one of the problems. How do you get heavy elements in the universe?
Sure.
And they say, okay, the Big Bang theory predicts that the earliest atoms to emerge from the dense particles superhydrogen and helium, because those are the two simplest, lightest weight elements.
Sure.
And they say, so most of the elements in the universe are hydrogen and helium, and the ratio is 3-1. Roughly 75% hydrogen, 25% helium, and then trace amounts of the other things. And they would tell you that using powerful telescopes and spectrometers, cosmologists confirm that the observed universe is 74% hydrogen, 25% helium, and 1% heavier elements. Sound good?
Is it really?
It is, as far as we can tell. Those measurements are pretty accurate.
Okay.
The problem, as we will see when we get into this, is that that's not what the Big Bang Theory predicted.
Oh.
This is a retrodiction.
Interesting. Okay.
So that's what we're looking at is the three evidences for the Big Bang. So as we say, there's the fact that the cosmic background radiation, the expanding universe, and the Big Bang nucleosynthesis. These were the three kind of linchpin arguments for the Big Bang originally. So let's look at some of these and see, do they really demonstrate the Big Bang? The cosmic background radiation, and we've touched on this before, the problem with cosmic background radiation is it's uniform in its level. It's 3 kelvins or so everywhere you look. Now, early astronomers said there would be a certain background radiation just because you have stars out there and they're giving off heat. You are going to have a certain kind of background radiation, and what we find actually is consistent with that. So there's no reason to see it as anything other than heat from the suns. In fact, the Big Bang Theory didn't predict that there would be a cosmic background radiation left over from the supposed expansion of the Big Bang. Sir Arthur Eddington, as I said, he predicted that there would be a starlight background radiation of about 3.2 kelvins, and he predicted that in 1926 before there was a Big Bang theory at all. So when the Big Bang theory came along, they had different estimates. They would have to have extra radiation in addition to that, and their radiation estimates ranged anywhere from 5 up to 50 kelvins.
I see.
And they sent up this, what's called the Cosmic Background Explorer satellite, the COBE, back in 1989. And it was supposed to measure fluctuations in the cosmic background radiation. What we measured to that point was this absolutely smooth background radiation, 3 kelvins, which matched what Eddington had predicted without the Big Bang. But if it's so smooth, where do you get the fluctuations that would give you galaxy formation? If it's same everywhere, you're not going to be able to get any place where you get an accretion of materials. Okay. It would have to be different in some places. So, as I said, in 1989, they sent up this Cosmic Background Explorer. It's called COBE, CO for Cosmic, B for Background, E for Explorer. And they found fluctuations. And this was announced to great fanfare in 1992. I remember this. It's all over. Maclean's magazine ran a cover article with a big headline, "Looking at God. Scientists proclaim that space images show the origins of the universe." And then in Newsweek, their headline is "The Handwriting of God. A satellite spies the ripples of the Big Bang." It's a general rule of thumb, by the way. The wilder, the more grandiose the claims, generally the less substance there is to it. And I start talking about looking at God and so on, you know that they're really overstating what's there.
Yeah, the media usually does sensationalize things.
Indeed they do. Now if we look at something a little more restrained, Scientific American in their July 1992 issue, their front page, cover headline was "More Proof for the Big Bang." And then they show this picture. It's sort of like an oblate spheroid in blue with big orange patches all over it. And under it says, "The COBE sky map shows telltale fluctuations in the temperature of the early cosmos." Now, it's a good thing they tell you what this picture is, because your average reader looking at this would have no idea what it's even supposed to be. Mm-hmm. But you look at it, you see this blue oblate spheroid, and you see all these orange patches, big orange patches covering probably at least half the volume or more. Who's going to argue with that? They don't even know what it is.
Yeah.
What is it? Well, the orange areas are supposed to be the different temperatures. And you look at all those patches, sure, there must be enough to explain galaxy formation, right?
Possibly.
Yeah, case closed, you would think. Then you look inside the cover and you look at where they explain what it is. This cover image shows the sky through the microwave-sensitive eyes of the Cosmic Background Explorer satellite. Orange indicates warmer than average regions. Blue shows cooler than average ones. Temperature variations are thought to trace the uneven distribution of matter shortly after the formation of the universe. Well, that's what you need, right? Mm-hmm. But you read a little further. This is a little box on the top of page 6. It says, "Most of the features seen here are instrument artifacts, however."
Wow.
What does that mean?
That means it's not actually there aren't actually fluctuations in the universe. It's actually just fluctuations in the camera gear itself.
Exactly. The actual anisotropies that they measured, the ones that are actually in the background, says they're too small to be seen.
What? Okay.
They were actually below the detection limits of the instruments.
Yikes.
So, but the picture you get on the cover sure makes it look like, hey, game over. In fact, the fluctuations were far too small to explain galaxy formation. Far too small. And it was not what the theory had predicted. So you're starting to get in a problem. It's the article, the one from Newsweek, that talked about the handwriting of God. It actually admits in the article that says these variations are not what's needed for galaxy formation. It's far too small for that. What Kobe actually found was that the large-scale anisotropies needed for, and that means difference in temperatures, needed for galaxy formation aren't there. They're not there, which would mean the Big Bang Theory is wrong. But that's all hidden. What the general public hears is, hey, we've seen God, we've seen the origin of the universe, we have proof for the Big Bang. Yeah, but the scientists know. McGuff in Astrophysics Journal writes, cosmic microwave background is very smooth. Structure cannot grow gravitationally to the rich extent seen today without leaving indiscriminately large fingerprints on the microwave background. And Hartnett adds, the large fingerprints are just not observed. And it gets worse for them. It gets worse. The Big Bang Theory would require a random distribution of galaxies throughout the universe. But that's not what we found. It began to find these clusters of galaxies. Galaxies are arranged in a very specific pattern of galaxies.
Sorry, before we continue, why would we expect a random distribution of galaxies?
Because the original Big Bang, all of the matter energy is inside this tiny little singularity, which then suddenly expands. Mm-hmm. And so matter is thrown out in all directions randomly. Mm-hmm. There's no pattern to it.
Right.
So the chance of having accretion at any point is just randomly distributed.
Right, okay.
So you should have that random distribution, but that's not what they found. And it led to a crisis internally, a crisis in 1986. Okay? Dwayne Gish of the ICR does a good write-up on this. And as he tells us, a fellow called Tully from the University of Hawaii demonstrated that there were ribbons of superclusters of galaxies 300 million light years long and 100 million light years thick, stretching out about 1 billion light years and separated by voids about 300 million light years across. Now, again, light years is a measure of distance, not time. But it's basically what you have is this pattern in the universe that looks almost like concentric circle or spheres. We get lots of galaxies and then a void between them with very little, and then another big. It's anything but random. And as Tully explains, these structures are much too big for the Big Bang Theory to produce. At the speeds at which these galaxies are supposed to be moving, it would require 80 billion years to create such a huge complex. Oh. But they tell us the age of the universe is like 13.6 billion.
Right.
Where did these come from then? And it got worse. In 1989, two scientists, Margaret Geller and John Huchra from the Harvard-Smithsonian Center for Astrophysics, announced the results of their research. Their map of the sky showed a structure they called the Great Wall, a huge sheet of galaxies 200 million light years across, 700 million light years long. Another team, the American, British, and Hungarian astronomers, discovered even larger structures. Again, the galaxies in thin bands with about 600 million light years of void, rough void between them. And this pattern then stretched across about a quarter of the diameter of the entire universe. And they would say, according to the Big Bang model, this kind of shell and void pattern would take nearly 150 billion years to form. And again, they tell us the universe is 13.6 billion. So what do you do with that? And let me remind you, this is not something the general public knows. This is not something that most of those Christians who use the Big Bang Theory as an apologetic and are happy to bend Genesis to fit, they have no idea about this. So what do? Well, they try fudge factors. They invent hypotheses to explain why their hypotheses didn't work. Dark matter, you might have heard of that. Mm-hmm. Cold dark matter. You need more gravitational pull to make these happen, so you need more matter. It's not there, so we'll just say, well, okay, it's not there, our theory must be wrong. No. You say, it's there. We just can't see it. We can't touch it. We can't interact with it, but it's there. 90 to 99% of all the matter in the universe is actually dark and you can't detect it. But it's there, otherwise our theory is wrong. And they're hoping that this cold, dark matter would explain the problem. But it really doesn't. because after they proposed that, you had more work and discoveries of the structures and their size, and they turned out to be so massive that even if you put in this cold dark matter, it still wouldn't explain their formation. So Saunders and the co-workers published in Nature, top scientific journal, they said that, look, the cold dark matter model can be ruled out to at least the 97% confidence level. And it kept getting worse. In 1991, the joint US-European Röntgen satellite, ROSAT, discovered that there are giant superclusters of quasars on the very edge of the universe, supposedly 8 to 12 billion light years from Earth. And so even if there was cold dark matter, it wouldn't explain the existence of these giant clusters of quasars, and yet they're there. Yeah, so here's the thing. There are insurmountable problems with the Big Bang Theory. If it weren't necessary to have an excuse to get rid of God, it would have been tossed ages ago. It's kept because you need something to try to explain origins without God. Now, another dodge they had then was this inflationary model. They said that once you have this initial expansion of this singularity, you went through a period of massive inflation. The expanding ball of matter energy suddenly stretched out with dramatic speed. And so before that, the part of the universe we could observe was so small that density fluctuations, you can't possibly find them. You can only describe them by probabilities. But then when the inflation began, these existing fluctuations were inflated to great size and became the fluctuations in the cosmic background radiation and the seed of large-scale structures in the universe. But as we said, as we've seen, it doesn't explain it. It's just not enough. It doesn't solve the problem it was invented to solve. Those fluctuations are not enough. Furthermore, inflation requires a density 20 times larger than what's implied by their model of nucleosynthesis. And we'll get to that when we look at that line of argument. There's no explanation. They can't explain why it would have happened. But it had to have, to keep our theory viable. It had to have happened. They have no explanation for it. And of course, there's no way to observe it or test it. So it's not science. It's out of the realm of science. And then, of course, during that, as we've mentioned before, during that inflation period, light is moving much, much faster than the speed of light. So this is your cosmic background radiation argument number one. It just does not do what it's supposed to do. The second line of argument was that the universe is expanding. Now, the idea is that the galaxies outside of the Milky Way, the galaxy we live in, are moving away from us at a rate proportional to their distance from us, which suggests that the universe is continually expanding from a single source. Immediately, do you see a problem with that? Even if the universe were expanding, does that mean it started from an original singularity?
Not necessarily.
Yeah, exactly. God could have built a universe with galaxies certain distance apart from each other initially, and then, as part of the natural world, started them moving. Right? That's very, very possible. Second thing is, how do we know they're moving away from us? How do we know? Well, the redshift. You know what redshift is, right?
Does this have to do with the Doppler effect?
Yes, exactly. Can you explain for our listeners what the redshift is?
Basically, when something is moving away from us, the frequency that its waves hit us is decreased. So think about a car moving towards you. When it's coming towards you, the pitch of the car is high, but then as it zooms past you and goes behind you, the sound of the car becomes lower. So this happens with sound waves, and this also happens with light waves as well. So the redshift is for something that gets farther and farther away from you.
Mm-hmm. Why is it called redshift?
Because the frequency of red light waves is lower than the frequency of blue waves, for example.
Yeah, so if you're coming towards you, what kind of shift would you see?
If it were coming towards you, you should see a blue shift.
Exactly. So an object that's giving off light waves. It's like, imagine if you have a pond of water. It's a still pond and you drop a rock into it. What do you see? You see these waves from where you disturb the water coming out from the point where you drop the rock, and they're moving away. And they're concentric circles, and the distance between them is the same on all sides. Mm-hmm. If you have a motorboat, though, for example, moving through the water, okay, it's doing the same thing. But as the motorboat moves, it's squeezing together the wavefronts in front of it.
Right.
And the wavefronts behind it get stretched out. Mm-hmm. So the wavelength gets longer. So you see light, and you're expecting to see a certain spectrum of colors in it. And you see that it's not what you expected. It's the light is moved more towards the longer wavelengths, more to the red end of the spectrum. I asked, why is it? Well, maybe it's like a motorboat. Maybe this object giving off the light is moving away from us. And so the waves in front of it, the light waves, are squeezed together, and the light waves behind it are stretched out into the red end of the spectrum. That's called red shifting. Mm-hmm. And we look at these galaxies around us, and we see a red shift in them. And then we think, well, this is why. And that's actually where the Big Bang started from. This was the first thing that started this observation that the universe seems to be expanding. But there's a couple of problems with that. If this is the explanation from the redshift, then the amount of the redshift would depend on the distance it is away from us. It shouldn't depend on the type of galaxy. You should have a random distribution of redshifts. But that's not what we found. An astronomer named Tift found in the 1970s that the redshift depends on the type of galaxy. Spiral galaxies, for example, had a higher redshift than elliptical galaxies. So that's a problem. How do you explain that? If the redshift is caused by things moving away from us, it should be the same regardless of the type of galaxy, but that's not what we found. Yeah. Then he found another startling discovery. Again, if the Big Bang happened, then the galaxies should be randomly distributed throughout the universe. All the galaxies should be randomly separated from us. So if we looked at the values of the red shifts, they should be randomly distributed. Mm-hmm. But they aren't. Redshifts appear to increase by quantum leaps, specifically by a leap of 45 miles per second. So they're quantized. Actually, they're not randomly distributed. So this a couple of issues that bring into question whether, in fact, this is the explanation at all for why these things are redshifted. It's interesting that Tift's work was published in Astrophysical Journal in 1976, the quantized redshift that he observed. Now, journals aren't supposed to do this. Scientific journals, they're not supposed to include a disclaimer saying, we don't endorse this idea, but they did.
Oh, okay.
But they couldn't find anything wrong with it. But why wouldn't Big Bang people like this? Well, if the redshifts are not randomly distributed, there's no reason to think it's due to the universe expanding, which means there you go. Your reason for believing the Big Bang is gone right there. Mm. Now, the third big argument we said is Big Bang nucleosynthesis. Big Bang predicted that you should have a ratio of 3-to-1 of hydrogen to helium in the universe and small amounts of the heavier elements. These are the two lightest. Hydrogen is the lightest, and helium is the next lightest. And cosmologists using telescope spectrometers, they've confirmed that indeed the observed universe is 74% hydrogen, 25% helium, 1% heavier elements. Does that sound reasonable? Does that sound like it could be good proof?
So far, I don't see any issues with it.
Yeah, no, you wouldn't. I mean, it looks great if it were actually true. Mm-hmm. The reality is that you look back at the historical data over the years before scientists actually measured these ratios, they find that the Big Bang didn't actually predict a ratio of 3-to-1. They had all kinds of different estimates, which they kept then adjusting to agree with whatever the observations were telling us. Okay? The estimated ratio is dependent on the ratio of baryons to photons. And baryons are your subatomic particles. Photons are little packets of light energy. And that's also been arbitrarily adjusted to degree to whatever we see. So when they say, oh, look, observations tell us there's a 3-to-1 ratio of hydrogen and helium in the universe, and that's what we predicted. Well, you didn't actually predict that. That's the problem. You retrodicted it.
Huh.
Once you knew it was 3-to-1, then you put that into your theory. And you can read about that in Mitchell, in Physics Essays, 1997, volume 10, where he goes through this history of it. But they got a bigger problem. Sure, let's retrodict 3-to-1 ratio. And then we're right, because that's what you have. The problem then became that once you put a 3-to-1 ratio in there, your mass prediction goes all wacky.
Oh, okay.
If the ratio is 3-to-1, then the mass of the universe should be 10 times what it is. So here's the problem with your theory. If the hydrogen to helium ratio is correct, then the mass is wrong. If the mass is correct, the hydrogen-helium ratio is wrong. They don't match observations. What should you do with a theory when it doesn't match observation?
You throw it away.
Well, you should, right? Or if you really want to get rid of God, what do? Well, you invent a fudge factor. And here's your dark matter again.
Okay.
We need 10 times as much mass. Hey, dark matter will do it for us. It really is 10 times as much mass. Just 90%. We can't see, we can't touch, we can't interact with it, but it's there. According to the current model now, the universe is supposed to be 73% dark energy, 23% dark matter, 3.6% intergalactic gas, and 0.4% the stars and the planets and so on.
Wow.
So, exactly.
So you're telling me that 96% of the universe we can't
see, we can't touch, we can't interact with it, but we're supposed to believe it's there.
Okay.
So this is the thing, when we actually look through the Big Bang Theory, it all looks so nice on the outside, but the more you dig in, the more you dig, you get to the center, you find there's a giant heap of trash. And it has to go, because even if we would accept this arbitrary invention of dark matter, we've seen that the Great Wall structure universe still, it cannot be explained even if you put in that dark matter. So it's a theory that, again, if it weren't necessary for atheism, it would have been gone long ago. The scary part in all this is how many Christians hitch their apologetics wagon to this bogus theory. And then they say, oh, look at this. See, science has just kind of proven. Science's Big Bang Theory is supporting God because it supports that there's a creation and so on. But here's the problem. As we've seen by all standards of real science, the Big Bang Theory should have been abandoned long ago. It's held on to only as a gambit against admitting there's a creator God. So why so many Christians think that this is great stuff is really not clear. Not clear to me. And what's going to happen when they do finally throw out this theory, when it does collapse under the weight of all of its inconsistencies? What's going to happen to these ministers saying, oh, look, so we're using the Big Bang to prove God? Well, Big Bang's gone. What happened to your proof for God? It's also gone. That's a bit of a problem. It's interesting that 1 Timothy chapter 6, 20 to 21 actually warned about this. And this is now about almost 2,000, not quite, almost 2,000 years ago, that Paul's writing to Timothy. O Timothy, keep that which is committed to thy trust, avoiding profane and vain babblings and oppositions of science, falsely so called, which some professing have erred concerning the faith. It's like a prophecy there. Now, they are creationists, like CMI, Creation Ministries International, would say that you shouldn't use this argument. This verse isn't really about evolution. And they will say this: the important thing here is the meaning of original Greek word translated science, which is gnosis, and in this context refers to the elite esoteric knowledge that was the key to the mystery of religions, which later developed into the heresy of Gnosticism. Now, as I point out, it's not an error by the King James translators, because in their day, science simply meant knowledge. It was interchangeable. But it's no longer means that. So they say this is not something that applies to evolution, theory of evolution, because it's really, in this context, refers to this mystery, this Gnosticism. Sound good? Do you think we should use it? Do you think we should not use it?
We can still keep using this,
Yeah, I think it's
passage. Yeah.
absolutely, it still applies.
Yeah.
Now, first, what is in the context that says this refers to Gnosticism? There's nothing. It's not about Gnosticism. There's no evidence that Gnosticism was even there as early as year 68, which is the latest possible date for First Timothy.
Okay.
Probably written around 63. Gnosticism just wasn't there. This Greek word gnosis is used 28 times elsewhere in the New Testament. It always simply means knowledge. Luke 1:77, it's knowledge of salvation. Romans 11:33, knowledge of God. So it's not referring to Gnosticism. It's not referring to this so-called elite esoteric knowledge. Yes, it's referring to knowledge in general, not just the theory of evolution.
Right.
Okay. But whether you translate science falsely so-called or what is falsely called knowledge, it certainly applies to evolution and to the Big Bang Theory and to old Earth creationism. It would be wrong only if we said that 1 Timothy 6:20 applies specifically and only to evolution. It doesn't apply specifically and only to evolution, but it certainly does apply to that.
Right. Yeah.
So again, it raises the question why so many Christians are taken in by this. And it is actually important. You remember that Jesus, in John 3:12, when he is talking to Nicodemus, he says to him, if I've told you earthly things and you do not believe, how will you believe if I tell you heavenly things? That's a very good question, because it's basically saying, look, if I'm telling you about things that you can check, earthly things, things you can see for yourself, and you don't believe it, you think I'm wrong about those, why would you believe me when I tell you about things you can't check?
Yep.
It's a legitimate question on Jesus' part, obviously. And it's very, very true. If you start going to the Bible and saying, it's wrong about this, it's wrong about creation, it's wrong about the age of the earth, but you should believe it on other things you can't check, why would we be surprised to hear the atheist or the skeptic say, well, why should I believe it on the things I can't check?
Sure.
When you're telling me it's wrong about the things I can check. I mean, your Jesus himself said you shouldn't. And that becomes the problem when Christians start hitching their apologetics to these kind of secular theories that simply don't agree with what the Bible says. And early on in this series, we did go over whether there's any way to make the Bible fit with old earth creationism, and there really isn't. And so you'd expect, again, that the skeptic would say, you don't believe the Bible, why should I? How do you get around that?
Yeah, that's a very good point.
And then there's another point I'd also like to make, and that's Jesus' words in Matthew 6:24. And he's talking specifically here about wealth, mammon. But I think it's a gnomic truth. He says, no one can serve two masters, for either he will hate the one and love the other, or else he will be loyal to the one and despise the other. You cannot serve God and mammon. And as I said, I think the principle, though, applies universally. You cannot serve two masters. If you have two masters on any issue, one of them is going to be your main master. You're going to be loyal to one of them and disrespect the other. There's no way you can be equally loyal to both. So when it comes to epistemology, how we know things, what is our epistemological master? Is it the Word of God? Or is it the pronouncements of atheistic science? You can't be both. Because sooner or later, those are going to clash. And you're going to have to pick one or the other. So when you start saying, well, the Bible, yeah, you know what? You can fit in billions of years. Yes, we can fit in the Big Bang. Who's your true master in that case? Is it the Word of God, or is it atheistic science? Which one? Which one are you being loyal to, and which one are you despising?
Yeah.
That's a question.
It has to be the Bible, but fortunately we don't have to make that choice, because that science isn't, as we saw all throughout this series, can easily just be tossed out.
Yeah, and that's why I specifically said atheistic science.
Yeah.
Okay, where they just basically, whatever the party line is, whatever the consensus view is, they just accept that as being true. No, God is the witness. God is a creator. God is the only one who was there at the beginning, who gives us his testimony. We need to go by that. Science is a very useful tool, and when used for what it's supposed to be, which is discovering how the world works, and not used to try to kick God out, then its findings, yeah, not surprising, will agree with what the Bible says. But if you don't know how or where the problem is, you don't see what's the cause of the confusion, maybe you don't know the science well enough, or you haven't looked into it enough, which one are you going to pick? I can respect the Christian who doesn't know science, who says, look, I can't explain why science seems to say something different from the Bible, but I know the Bible, I know it's the Word of God, I believe it. But to take the Bible and say, well, we're going to start changing it to make it fit what the atheist scientist says, that's, to me, a very dangerous way to go. Okay, any questions on any of this?
None that come to mind. That was a lot to take in and will require some time to keep thinking about and looking into and digesting. Yeah.
All right. I'll leave you with a couple of more recent examples, because I gave you some examples and some of them are from years ago, but to show that this is ongoing. It's always happening. These attempts to push evolution in totally bogus fashion. Remember, I gave you examples, supposed examples of evolution, which were not that at all.
Right, like the moth.
The peppered moth, the wife beaters of Cabal. Remember that,
Right,
the chimpanzees who hit the female chimpanzees. The animals around Chernobyl that just die younger now. And I said two questions, like why do they never give us an example of actual evolution, and B, why do they give examples of evolution that they know are not examples of evolution? Here's what this is from Wall Street Journal, September 25th to 26th, year 2021, so very recent. The headline of this article, some species are changing along with the climate. Warmer conditions have prompted animals and plants to adopt new habits and evolve new traits. Squids are shrinking, lizards are growing bigger toes, and trees are migrating. Now, are they evolving new traits? You read through the article, you find fun stuff like these type of birds. They would eat plankton in a certain area. And now you get supposedly melting glaciers, and they can't find plankton in the normal place, so they've gone to a different place to eat plankton. Does that sound like evolution?
No, it sounds like they're just trying to find food.
They talk about butterfly fish. Butterfly fish used to fight with each other for food around the coral reef.
Okay.
And saying, oh, now these coral reefs, they're exhausted from food because of climate change, they're not producing the food. The butterfly fish don't fight anymore. They don't fight over food since the food's not there. Is that evolution? But we're being told, these are the examples we're being given. And then they're going to give us actual evolution. And it's towards the end of the article, evidence from another small lizard shows that climate adaptations aren't limited to changes in behavior or lifestyle. Some species are measurably evolving and fast. Okay? And remember, what is actual evolution? You want to go from amoeba, single-celled organism, up to man. You need to develop qualitatively new genetic data for new features. Without that, it's not evolution. So, but here, these are measurably evolving. They're not just evolving, you can measure it. And it's happening so fast. So what's happened here? Back-to-back hurricanes Irma and Maria battered the Turks and Caicos Islands in 2017. They flattened buildings, uprooted trees, and left the community reeling. They also created a rare scientific opportunity. Surveys of a local species of anole, a distant cousin of iguanas, had just been completed prior to the storm. So they turned their attention to the impact of the hurricanes. What they found was survival of the fittest in action. Lizards in the post-storm population all had larger toe pads and stronger front feet, better suited to gripping trees in high winds.
Okay.
And those traits were being passed on to the next generation.
Sure, yeah, that makes sense.
So think about what's happening. You got these anoles, these lizards, and they're clinging to the trees.
Yeah.
And the hurricane comes. And the ones that have tiny little feeties,
they can't grab on.
They can't grab on strongly enough. They get blown away and killed.
Yep.
So you've killed off, in the population, you've killed off the small-footed anoles. So you're left with large-footed anoles. And they pass on their traits because they survived.
Yeah.
So a trait that's already there in the population is being favored by natural selection. It certainly is natural selection. It is survival of the fittest.
Yeah, that's true.
But it's not evolution, is it?
Not at
The
all.
Anoles didn't become anything other than Bigfoot Anoles, which they were all along.
Right.
And yet we're told, while scientists expected to eventually see evolution in reaction to extreme weather, many were stunned that it could happen so fast.
Wow.
So now you know what to look for. You begin to notice this all the time.
Yeah,
They keep
that's-
giving us these
yeah.
examples that are not evolution at all. But again, what the headline says in the subheading, evolve new traits. The box in the middle says many scientists are stunned to see evolution take place so fast. And people are going to read that and say, well, yeah, more examples of evolution. They won't even read it. They won't even understand it.
Oh, man.
And then from New Scientist, this one's from July 17th, 2021. It's usually a few weeks later. It comes out in Canada, which is why it's a couple months back. But why don't we jump on the COVID bandwagon? They have an article here that says, a genetic gambit. We're not taking evolution into account properly in our pandemic strategy. Here's why we must change tack. And they're talking about our reaction to COVID-19. And it says, earlier this year, Dido Harding, whilst heading England's coronavirus test and trace system, said that no one could have predicted that new variants of SARS-CoV-2, the virus that causes COVID-19, would emerge. Of course this was predicted. And while some people question Harding's statement, many still seem surprised that the virus continues to mutate. And so the author of this article goes on to say, see, that's the problem. People don't understand. Only if only they would understand evolutionary thinking, modern evolutionary theory, then we'd be better off in fighting COVID. Okay, we're not using evolutionary theory. According to this guy, we'd be better off if we did. Now, here's the thing. Was that predicted? Of course it was predicted.
Yeah.
Okay? This is mutation and survival of the fittest. Okay? The virus does mutate.
Yes.
Now, there are different types. Some don't mutate much. Coronaviruses are very adaptable to mutating. And they do mutate.
Yeah.
And so new variants arise. And that's predictable. Anybody who knows basic science already knew that.
Just like the seasonal flu.
Yes, and we can, which are also coronaviruses. And we can actually predict which way it would mutate. Okay? Because remember, they want to survive, survival of the fittest. The problem with particularly deadly viruses is it kills off the host. And when the host is dead, the virus dies. The virus cannot pass on. On the other hand, if the virus isn't very transmissible, it's not a very contagious sort of illness, then also has trouble passing on.
Right.
So if they become more transmissible, then that enhances their survival. If they become less deadly, that enhances their survival. So you could predict that this is the way it's going to evolve, develop, mutate. Again, new strains which are more infectious but less deadly, which is exactly what we have. This Delta variant is much more contagious, but it's much less deadly. You don't need to know evolutionary theory to know that. How would evolutionary theory help you on this? Does the COVID virus become anything other than a COVID virus? Is it evolving, developing qualitatively new genetic material for new traits? No. Okay, so this is the problem. It's not evolutionary theory. So you got kind of a coattail fallacy here where they want to say, oh, you will understand us better if we understand evolutionary theory. When in fact, you don't need to understand evolutionary theory at all. It's got nothing to do with it. These kind of examples are going to be around all the time. They never stop. You know to look for it. You will spot them again and again and again. So I think we've reached the end of our unit on evolution. There are always other topics to talk about, and maybe someday we'll revisit a topic on creation evolution. But I think we've covered what really counts to show that the theory is false, not just because the Bible says so, which it does, but also because it's scientifically impossible. And we've shown so many different ways that it absolutely cannot happen, and that therefore we're being given fake examples to try to support the idea. We looked over the issue of how old is the Earth? Does it fit into the 686 year maximum that the Bible says, or does scientific evidence prove that it's billions of years old? We showed that the supposed evidence for billions of years old really don't show that. Whereas there are many lines of evidence, scientific evidence, which they will not show you unless you go and look for it, that put the Earth at less than 10,000 years old.
Right.
And then that Big Bang Theory, which for some reason is being used as an apologetic by so many Christians, simply doesn't work. It's scientific science. Hard science has already debunked it. So it's time, I would say, to stop trying to use what comes to atheist science to support the Bible. We don't need it. Let's just support the Bible and go with that. It is the Word of God. Any comments?
Amen. Yeah, thanks, John, for going through all these examples with us, and not just that, but also giving us tools to challenge these new articles when we see them.
Hello everyone. Due to the massive amount of content for this series on evolution, we have broken it down into 3 different parts. And we hope you continue to listen and enjoy the series.
Thank you for listening to the Truth in My Days podcast with John Torse. If you like our content, please share this information with family and friends. It helps us a lot. We also would love to hear from you. You can reach us on Facebook, Instagram, and YouTube by searching Truth in My Days as one word again. Truth in My Days as one word. No spaces in between. Or reach us by email at info@truthinmydays.com. You may also visit our website for more comprehensive material and to learn more about our ministry. Our website is truthinmydays.com. Thank you.